On page 513 and 514, we are looking at linear inequalities. So we've had linear equations and systems of them. Now we're going to look at linear inequalities. So you have solved things like 2x is less than 6, x is less than 3, and then you put a 3 on there, an open circle, and you went to the left. You don't need to write any of that down. All right, so that is one linear or an inequality. Now we're going to look at putting two variables together. For the most part, once in a while you'll have just an x or y still, but it's going to make a line. All right, your solutions are all ordered pairs that make the inequality true. So when you graph a regular line, we extend it in both directions and put arrows on because every single ordered pair that you would get makes that equation true. So that happens again with inequalities, only there's even more. The first thing we're going to look at is how you determine whether an ordered pair is a solution to a linear inequality. So you do that just by plugging it in to see if it's true. So if we look at the first one, 2 times 2 minus 3 times 5, we're asking, is that really less than 15? So 2 times 2 is 4, 3 times 5 is 15. Is that less than 15? Well, you would get negative 11 is less than 15. So this one is a yes. For the middle one, 2 times negative 1 minus 3 times negative 7, is that less than 15? If you don't need to do that first step where you write it out and you can just multiply it, that's great. Negative 2 minus negative 21, is that less than 15? That becomes plus positive. So 19 is less than 15, which is not true, so no. Go ahead and try the last two to see if you can get those. So 2 times 3 minus 3 times negative 4 is less than 15. 6 minus negative 12, less than 15. 18 is less than 15, so that one is a no. The last one, plugging 0, 0 in should be really simple. You shouldn't have to write this out, but you can if you want. 0 is less than 15. Yes, so the first one and the last one were the two that were solutions to the inequality. So now we are going to graph these. So when you are graphing them, there's a few different things you have to watch out for. The first thing is you want to put it into slope-intercept form. You can still do x or y intercepts if you would like to, but that will change how you shade. So it's up to you if you want to do that or not. Remember, slope-intercept form is y equals mx plus b. B is your y-intercept. That's where you start by going up or down, and then you count rise over run for your slope, your m value. So the only difference is you'll have an inequality sign rather than an equal sign. When you connect your dots, you're either going to have a solid line or a dashed line. Just like when you did x is less than 3, you would have an open circle. So when we had inequalities before, we had to decide if we had an open circle or a closed circle. So now we have to decide if we have a solid line or a dashed line. So a solid means you include the numbers on the line, so less than or equal to or greater than or equal to. So that would be like a closed circle. The dashed line means we're not including them, so strictly greater than or strictly less than. So what kind of helps is that if you have a line underneath, your line should be solid. So that's the first difference. The second difference is that now, since it's an inequality, we have to shade. So you are going to shade above the line for a greater than or equal to, and then you will shade below the line for a less than or equal to. I will show you another way also in case you want to not think of it that way. All right, the other thing up here, make sure that you flip the inequality sign if you multiply or divide by a negative. That will happen quite a lot. So this is going to be the most difficult it gets right here. First, we have to solve for y. So to do that, you subtract 2x from both sides. So every time you will move the x over, negative 3y is less than, write your x term first so it's in slope-intercept form. So negative 2x plus 15. Then you need to divide everything by negative 3. So since I divided by negative, I need to flip the sign over. So y is greater than positive 2/3 x minus 5. So when I graph, I start by going down 5, up 2, right 3. Normally I would do that more than once, but that's all that will fit. Now, it's a strictly greater than, so I need to do this with a dashed line. So this is easier to do with a ruler, but you need to show that there are breaks in your line. It is not a solid line. When you decide where to shade, you have to go off of the one that you solved. So we flipped the sign so it became a greater than sign, so that means we have to shade above the line. If you want another way to decide where to shade, what you do is you pick an ordered pair that is not on the line. So the easiest one to pick is 0, 0. So you're going to plug 0 in for x and 0 in for y into your equation, your inequality down here. 0 is greater than 2/3 times 0 is just 0, minus 5 is negative 5. 0 is greater than negative 5. That's a true statement, so then you shade where 0, 0 is. If it would have been a false statement, you would have gone on the other line, other side of the line. Okay, so again, you can go by up or down based on greater than or less than, or you can pick an ordered pair and plug it in. If it's true, you shade on the line where the dot is. If it's false, then you go the other side of the line. So let's look at number 1. Number 1, we start by going down 5. And then our slope is 1/3. So up 1, right 3, down 1, left 3. It is a greater than sign, so that would be dotted. You still put your arrows on. It's a greater than sign, so we think we should shade up here. Another way to check is you can just pick an ordered pair and make sure it does work into where you shade it. But I like to pick 0, 0. 0 is greater than negative 5. That's true, so we did shade in the right place. Number 2, we start down 1, down 2, right 1. We can also go up 2, left 1. This one is a less than or equal to, so now we would have a solid line. It's a less than sign, so that tells us to go below the line. So we think we should be shading down here. So I'm still going to pick 0, 0 to see if my trick works. So 0 is less than or equal to negative 1. That is false. So 0, 0 is over here, so that means I should have shaded on the other side of the line. So that is correct. Number 3, first I need to solve, so subtract 5x from both sides. Negative 2y is greater than negative 5x plus 12. Again, you want to write your x term first so it's in your slope-intercept form. Divide by negative 2. Y is less than 5/2 x minus 6. We needed to flip the sign because we divided by a negative 2. So I start down 6, and then up 5, right 2, up 5, and right 2. Oops, I only went up 4. There we go. It's a less than sign, so it needs to be a dotted line or dashed line. And then we need to go below the line because it's a less than. Again, if I check 0, 0, 0 is less than -6. That is false, so I was right to go on the opposite side of the line. Number 4, subtract x. -4y is less than -x plus 8. Divide everything by -4. So I need to get y is greater than. I need to flip the sign. Positive 1/4 x minus 2. So down 2, up 1, right 4, down 1, left 4. This would be a dotted or dashed line. Again, I don't have a ruler, so that makes my lines not look very good. It's a greater than. Again, you have to go by what you solved, so we think we should be above the line. I would check 0, 0. 0 is greater than -2. That is true, so I was correct to shade on that side of the line. Number 5, subtract your x. -y is greater than or equal to -x plus 8. We need to divide everything by -1. Remember, there's a 1 in front of there. So y is less than or equal to x minus 8. Don't forget to flip the sign again. So we start down 8, up 1, right 1. We can go down 1, left 1. That is a solid line because it's an or equal to. We flipped it to a less than or equal to, so we think we should be below the line. Again, if I plug in 0, 0, 0 is less than or equal to -8. That's false, so I need to go to the opposite side of the line. So we did that correctly. Number 6, subtract 3x. 2y is less than -3x. Divide by 2. Y is less than -3/2 x. So that means I need to start at 0, 0, down 3, right 2, up 3, left 2. I would have a dotted line or dashed line. So it's a less than sign, so we think we should be down here. If we use the trick I use, we cannot plug in 0, 0 because it's on my line. So I would pick 1, 1. So 1 is less than -3/2. That is false, so I was correct in where I shaded. The last two, I don't have an x and a y in both of them. All right, so remember, if you have an x and a y, you should have a slanted line. If not, it should either be a straight up and down or straight across. So for 7, y equals -4 means I go down 4 to start, then I draw straight across with a solid line. Less than would be below. Number 8, I have x is greater than 7, so I would go right 7, put my dot straight up and down with a dashed line. Greater than would be to the right. So now we don't have above or below. When you have x equals, you're going to have to go right or left. Greater than 7 would be to the right. So graph your line, know whether it needs to be a solid line or a dashed line, and don't forget to shade.